Hi class, I can't be with you today, so I feel bad about that, but that doesn't mean we still can't have a little lesson. So all I want you to do is try to pay attention, and so we could get started on the next unit. And then tomorrow, if you have any questions on what I'm doing or saying, you could always ask me. So right now, all you have to do is just kind of listen and pay attention. So the first thing we're going to talk about are conditional statements. Conditional statements you have heard before. There's statements that have two parts to them. So before we even start talking about that, I know you guys can do this. It's saying determine if the following statements are true or false. And we've asked you to find a counterexample, and if you can find a counterexample for a statement, then you could say it's false. So let's look at number one. Okay, here's number one. It says the measure of an obtuse angle is less than 90. So we have to take this part of the statement as being true. So we know it's got to be an obtuse angle, but we got to find something that's not less than 90, okay? So what angle is not less than 90? An acute angle, so this would be number one. An obtuse angle, we could say it's 100 degrees, and let's check. Is 100 degrees less than 90? No. So there's our counterexample, we're done. So that would be considered false, okay? So an obtuse angle is not less than 90 degrees. So to find if it's false, you have to just try to find a counterexample, and if you can't, then you say it's true. Okay? So let's look at number two. Let's see, we'll make that blue. Number two says all supplementary. So I know in your heads, I know what number you're thinking of. You're thinking of 180, right? Okay, all supplementary angles are congruent. Okay, so supplementary angles have to add up to 180 degrees. But do they always have to be congruent? So can we think of a counterexample, supplementary angles that are not congruent? Well, what about, let's use that 100 again. So we have 100 degrees, so the other angle would have to be 80 degrees. So those two angles are supplementary, but they're not congruent. So that statement's false. All right, here's an algebra one. Okay, it's not a geometry one. Every prime number is odd. Now, I know you know prime numbers are numbers that the only number that can go into it evenly is itself in 1. So a lot of kids think, okay, 1 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime. So you might say, yeah, you know what, all those are odd numbers. Okay, so you might say that's true, but I don't know if you realize it or not, but 2 is a prime number because the only number that can go into 2 evenly is 2 and 1. So that fits the definition of a prime, so this is also false. Okay, I'm going to put the little false up here because 2 is an even number. All right, and let's do the last one. I'll make that black. So the last one says any 3 points are coplanar. So what was the definition of 3 points? Okay. If they didn't land in the same line, they would make a plane, so they would have to be in the same line. And if you put them all together, okay, I wonder if they would have to be in the same plane because let's see if we could, let me make this line better, okay. So we could have a plane up here, and we can have a plane down here, and we can have a point there, and a point there, and then another point, let me make another plane down here, and we can connect those points. Are all those points in the same plane? No. So here's that's a little tricky, but this is a good counterexample to show that no, just because you have 3 points doesn't make them coplanar. They have to be non-collinear. So that one was false also. So you had practice doing that, and remember I call it the Mr. Cochran method. To find your counterexample, all you have to do is put a not in front of the second statement. Put a not in front of the second statement and try to make that happen. Okay, so let's move on to, that was just a little warm up, get you all warmed up, ready to go here. So let's go on to the next page. All right, let me maybe make this a little bigger so you can see it better. Okay. All right, so a conditional statement has two parts. This is what we're going to be talking about. The hypothesis is the part of a conditional statement that is after the if, when written in if-then form, okay? The hypothesis is the given information or the condition. So you're given that to work with. That was like the first part of your statement where you had to have that be true. The conclusion is the part of the if-then statement that follows the then, okay, written in then form. The conclusion is the result of the given information. So sometimes it's true and sometimes it's not. But a conditional statement is what we call an if-then statement, where the if part is the hypothesis and the conclusion is the then part. So those are two new words that when I get back, we could stick those into your dictionary because you'll need those. All right, let's look at the next page. All right, let me make this a little bigger for you. Okay. All right. All right. The converse of a conditional statement is what you do when you switch the hypothesis and the conclusion. So you have to like switch them. So the conclusion is going to go first and the hypothesis is going to go second. So let's say this is our conditional statement. If two angles are vertical, then they are congruent. This would be the hypothesis. This would be the hypothesis, and this would be the conclusion. So if you want to write the converse of an if-then statement, you take the conclusion and put it after the if, and then you take the if statement, the hypothesis, and make it the conclusion. So then to read it, you would say if two angles are congruent, then they are vertical. So that's two different kinds of statements we're going to look at. The original conditional, which is if then, but then the converse is what you do when you switch them. Okay, so let's practice. Okay. All right, it says underline the hypothesis, circle the conclusion. So let's underline the hypothesis. And I know everybody always thinks it's the first part, but you got to be careful. Sometimes it's not always the first part. Okay. If today is Thanksgiving, then today is Thursday. So what's the hypothesis? Is if today, not the if, but today is Thanksgiving Day. Okay? The conclusion is going to be then today is, not then, today is Thursday. The if and the then are not part of the hypothesis or the conclusion. Okay? All right. A number is even if it is divisible by 2. So there's the tricky one. A number that's divisible by 2 would be the hypothesis, but then the number is even would be the conclusion. So in this case, the then is like pretending to be there. Okay? So those are a little tricky when they're written that way. Okay, the next one isn't too bad. If an angle is acute, so you have an acute angle, then it is less than 90 degrees. It is less than 90 degrees would be the conclusion. Okay, so the only ones you have to really be careful of are the ones that are kind of written backwards. All right, hopefully everybody's getting this okay. And let's go to the next slide. I make it bigger for you. All right, so here we want to write a conditional statements from the following. So the statements don't always have to be written in if-then form, but you'll see later on when we're doing proofs, it's really handy to look at it as an if-then form. So let's look at this first one, okay? An obtuse triangle has exactly one obtuse angle, okay? So if, I'm just going to use the symbol triangle, is obtuse, that's what's given to us, that's what we have to work with, then it has one I'm going to run out of room here, obtuse angle, period. So the if part is my hypothesis, the then part is it has one angle. So sometimes you have to reword it a little bit to fit the if and the then in. Okay. How about complementaries are acute? Okay, so we got to start with if. I'm going to start back here. If two angles, because you have to have two angles, are complementary, I'm just going to abbreviate it so I don't run out of room. If two angles are complementary, then what are we going to say? We're going to say then what? They are acute. Okay, getting the hang of this? Oh, I really like this last one. So we've got, we've got geometry teachers are really smart. So the if part, if a person, see how you have to kind of reword it a little bit, is a geometry teacher. Oh, what color should I have made that? This should have been red, right? But I'm going to just keep it blue. Then they are really, really, really smart. Right? Okay. I kind of added on some extra relays. Okay, sorry about the switcheroo, but this is this part. The if part is the hypothesis. The then part is the conclusion. Okay. All right. Example 3. On this one, they want you to write a conditional statement for supplementary angles add up to 180 degrees. Okay, wait, let me erase this little line here. Oh, thought there was the eraser. Oh, sorry, I thought I could erase that. I won't worry about it. Okay, write a conditional statement for supplementary angles add up to 180 degrees. Okay, so what's going to be our if part? I'm going to make it red this time. If two angles are supplementary, I'm sorry, my writing is even messier on the iPad here than it is on the board. If two angles are supplementary, then they add up to 180 degrees. Okay, there's my if-then statement. My hypothesis is in red, the conclusion is in blue. Okay, now what do they want us to do? They want us to write the converse. So if we want to write the converse, we have to say if two angles add up to 180 degrees, then what do we have to use? We have to use the if part of the conditional statement. Then they are supplementary. Okay, so it's not hard. You just switch it around. Once you have it written too, it's easy to just take the exact words and switch it around. Okay, let's look at, all right, example 4. So we're going to write the converse and of these. Now notice these are already in if-then form. Do you guys see that? That's the conditional statement. So what all you have to do is write the converse. So I can't see who's answering or thinking in your head because I'm not with you, but is everybody thinking they know what to write? Okay, I'll give you a couple seconds here to think about it. You know you're going to have to start with if, okay? But if what? Oh, I can't use this. I got to use the second part. If the next month is October, then this month is September. Okay? Pretty easy. And again, I apologize for how messy this looks. But it's just how it comes out with this pen. Okay, let's look at the next one. If two angles are vertical, we've been talking about vertical angles forever, it seems like, then they are congruent. We must have said that thousands of times. So now we're going to say the converse. If two angles, because it has to be two angles, are, and I'm going to use the symbol for congruent instead of writing it out, then the angles are vertical. Okay? And remember, that doesn't necessarily have to be true because you can have two angles that are congruent, but they don't have to be vertical. Okay, but I'm just asking you to rewrite it. You don't have to worry about if it's true or not. Okay, one more thing. So, make it a little bigger. Okay. All right, write the conditional and the converse for each statement. So I want you to take a look at it. Do you know, can you figure out what the if is and what the then is? Okay? And once you get the if and the then, you could write the converse. So let's do the if. So what are we ifing? If, what do we have? Oh, if the sum of two odd numbers, I'll just use the symbol for numbers. If this, what did I do wrong? That's not how I want to write that. Now see how I started out because if the sum, and I just started writing what was there. That's not really what I want. Let me see if I can erase this. Oh, there we go. So you don't always start out with exactly the same word. So I'm kind of glad that happens. Let me think about this. If the sum of two odd numbers, so what are we given? If you take, if you add two numbers that are odd, okay, so let's say it that way. If you add two odd numbers, then the sum will be even. Or you could say the answer will be even. Do you see how I had to think about it a little bit? So I'm glad that happened. And that's going to happen to you too. You might write and say, well, wait a minute, this isn't making sense, and you just have to kind of rearrange your words. So isn't that what we're given? We're given that we have two odd numbers that we're adding together. Then what's the conclusion? That the answer, the sum, has to be even. Okay. All right. Let's look at the next one. 3 non-collinear points form a plane. Okay, so what's our if? If you have 3 non-collinear points, then you have a plane. Ta-da! So, that's pretty much it for conditional statements and converse of conditional statements. So I'm leaving you with a little worksheet. You could be with your shoulder buddies and help each other. See if you can come up with a good if-then statement or a converse, whatever I'm asking you to do. If you listen to this nicely and politely, I'm going to say thank you very much. I appreciate it because I was thinking about you when I made this, and I miss that I'm with you, but these things happen. Okay, well, I'll see you tomorrow, and you can tell me all about if-then statements. Okay, goodbye.